Well, thank you, Marina. So, good morning, everyone. I'm Erik. And when I was asked by Magnus and Per to give a presentation on 5G technology today, I mean, my root and heart is in radio. That's what I love doing. That's where I've been doing most of my work during my 20 years at Ericsson. But I thought you probably know things about how we get shorter latency down to half a millisecond by shortening the TTI, and how we can use advanced antenna systems to improve the link. And you can read up on that stuff elsewhere, and that is not controversial. That is going to happen. But I thought that now that I have a chance to present to this set of distinguished ladies and gentlemen and really smart people, why not take the opportunity to bring up some of the other barriers that we see for the uptake of 5G, which are associated with technology, even though it may not look like that at first. So I think we saw an example of that already yesterday when Peter from Boliden, he said that, we have already done virtual reality distance driving our machines in the mines. We demonstrated that at the Mobile World Congress, and we used 4G. That was good enough. But he also said, but I'm really concerned that if I'm connected to a mine in Britain, and by chance there is the decisive Premier League game between Tottenham and Leicester, people start to watch TV, and I lose the connectivity to my mine. That is what concerns me. So that's another type of barrier which prevents them from using the technology. And I work with architects, so why should I be concerned about this stuff? Well, I think that many of the barriers that we see are associated with the business ecosystem in our industry, how we have formed ourselves to work around the mobile broadband services, and that has manifested itself in how we run the mobile networks, how we are organized, what business interfaces we have, etc. These are sometimes in the way for the new things that we want to accomplish. And if you think about it, that is to some extent associated with architecture. Because architecture, now I'm talking about the functional architecture, logical blocks and interfaces and stuff. The interfaces which are open and published are the interface across which different parties in the ecosystem interact, and how these interfaces are built determines to a large extent how different entities can interact with each other. So that's where we have separation of concerns, that's where we do business, that's where we take responsibility for a set of value-added services. And just to give you one simple example of how a new interface completely can change an existing business, we can take the technology interface associated with hardware virtualization. That is something that has come over the last 6 or 7 years, and it has now come to the telecom industry, so that in ETSI, we're specifying what we call the NFV interface, which essentially means that you can virtualize the hardware and expose that to the applications. And since this becomes an open interface in the architecture, that really disrupts the business, because from Ericsson's side, we are used to deliver pre-integrated software and hardware nodes. And now all of a sudden, because you inject this new interface, you have the possibility to sell hardware or hardware as a service without selling software, and you can focus on software and lease hardware as a service to somebody else. So I think that's one very simple and example of how a new interface in the architecture can really disrupt the business and the way that we do business. So I will start by giving some examples of barriers that I have seen when I talk to the industry. And I would like to start with when we visited Orange in France about 1.5 years ago. And this was on the theme massive machine type communication. So these are then the devices which have very low requirements on bandwidth and throughput, but there are going to be zillions of them, and low cost, lifetime cost is really important, long battery lifetimes are important, etc. And this was at the time when 2 new technologies for this segment had emerged. It was LoRa and Sigfox, both of them working in the unlicensed band. And in particular, Sigfox is interesting because it has a different business model than the other technologies, in that it's a proprietary system where Sigfox as a company build a network, and then they lease out capacity from this network, for instance, to operators. So as an example, if I was Orange and I had a customer like Town of Paris who wanted to come to Orange to connect a lot of sensors over the Town of Paris, they would go to Orange, and Orange would take the business. But Orange, in turn, would go to Sigfox and ask them to fix the connectivity. Sigfox would provide devices that I can provide to the Town of Paris. And then the traffic goes through the Sigfox networks, through the gateway, up to the Sigfox servers, and there the data is shared with Orange and the Town of Paris. So it's a different business model. And of course, we from Ericsson wanted to promote the fantastic capabilities of the 3GPP standard in this area. We had some good news for Orange. We had got commitments from device vendors that they could see that the cost for device would go down from $10 to $5 to $2 over the period of 2 to 3 years for the narrowband IoT. And from Ericsson's side, we had just secured that the upgrade to narrowband IoT was just being software upgrade to Orange. So we had also secured the long battery lifetime. So we thought that those barriers were gone, and we were happy to tell Orange. And to our surprise, Orange said, well, that's all good and well, but even if you give us the software for free, which we know that they will not do, and even if we get the devices for zero cost, it is still more costly for us to have this, provide this ourselves, than to go to Sigfox and lease the service. And the reason for that was that they had their internal structures set for mobile broadband based on the ARPU of $10 to $20 per month. And just the internal cost and of bringing a new subscriber in was too high, even if the equipment was for free. And also they said that configuring things which we need to do for the narrowband IoT standard isn't the same system as the mobile broadband. So there is a risk for us too, that entering this small business into our big system introduces risk for the mobile broadband services. If we do it with Sigfox, it's risk-free. And it's a pay-as-you-grow model since it's as a service. So obviously there were some barriers here for them to enter here, and since, of course, time has passed since then, and some of the barriers may have been addressed, but at the point, they pointed out that some barriers which had to do with their internal structure, and it had to do with the way that risk management and the inability to separate different businesses in the technology. Another example is we talked to Daimler, the Mercedes provider. And we went down there to talk about 5G. They were curious about 5G. What can 5G bring us for us? And we started to listen to their concerns. And a small, maybe seen as a small thing in the whole scheme. But one concern they had, they said, well, we have a car that sits in the parking lot for 2 weeks at an airport, for instance. And we want to make sure that the car can be started, so the battery must not be flat. So we have a very strict requirement on how much battery the car can consume when it's parked. And so we put in a dormant state, and then we want to wake it up. But we have noticed that after a day or two, or even after a few hours, the car is not reachable anymore from the data service. So we wake it up by means of an SMS. And that is a concern, because most of our cars are in a roaming situation. We use Deutsche Telekom, or rather we use Vodafone from Daimler. As a global connectivity provider, most of our cars are in markets where Vodafone is a roamer, so we use the local network. So most of the cars are in, I think that is typical for the car industry, most cars in a roaming situation. And an SMS can take 3 to 4 minutes to arrive. And for a premium car manufacturer, that's not a good thing if you want to do things, put on the heating or unlock your car remotely, and it takes 4 minutes for the car to react. So maybe narrowband IoT, they said, we heard about that. And the thing is that the reason for this is the touch timer in the network, that after some time of inactivity, you can set a timer that revokes the IP address and removes the user from the system, and then you need to trigger from the core of the device to restart the session, if you like. These timers can, in principle, be set to weeks or even years or indefinite, and that's a simple configuration. I say simple reconfiguration in the operator network, in the Vodafone network in this case, would solve the problem. No need for new technology. But first of all, that timer has not been implemented by us because there has been no need for mobile broadband, so it would be a lead time for 1 or 2 years. And secondly, the way that we from Ericsson and other vendors get paid for our software is through software licenses. And we associate that with number of attached subscribers. It's a way to make big operators like AT&T pay more than small operators like Mobitel Slovenia because they have more attached subscribers. But that also triggers the behavior that you don't want as an operator. You don't want to have users attached longer than you have to, because that will cost you money and that you have more attached subscribers, at least in some payment models. So that also made it, it was a barrier for, in this case, Vodafone to reduce that timer or increase that timer for Daimler. And also, there is no way in the system today really to automatically form these subscriber groups and say that this subscriber group should have this kind of configuration settings and that subscriber group should have other settings. So once again, isolating the services in the network is a rather manual thing to do, which introduces cost and it introduces risk. Another problem that the car industry tells us about is coverage. And in particular, even in situations where you have coverage from one operator, you don't have coverage from the other operator. So national roaming is something that would help a lot. That's a barrier, the inability to share the infrastructure which is really there. Another example of that and how you can solve that is in the United States. There was a power utility company who wants to connect all their power meters, and they want to, or also other type of equipment. And they said that AT&T does not have sufficient coverage to cover all our devices, and Verizon does not have sufficient coverage, but combined you will. So why can't you provide us with a service where we use both of your networks? And we don't want to configure our devices manually depending on where we happen to put them. So Verizon in particular compete with coverage, so they don't want to collaborate with AT&T and others in the mobile broadband segment. But they also realized that we will not get this business unless we collaborate. So what they did was that they went to a Swedish telecom provider and asked, why can't you set up an MVNO structure for the purpose of this particular customer? And we will make sure that you get to roam in both AT&T and Verizon network. So the solution to that was to let Ericsson be an MVNO for this particular power company, and then we could use both networks. But that is a solution that only works in some cases. And I do believe that one of the architecture issues that we should work on is to enable better interfaces for network sharing, for national roaming, maybe neutral host solutions, etc., where you can have a third party that owns the infrastructure and lease out capacity to the operator, the connectivity provider, who happen to have business in that area. So that is some architectural improvements that we can do. One of the barriers that I refer to, and something that we're working with, is the one that has to do with business isolation and the risk management of having a small service from a profitability point of view running in your network in parallel to the big service. And that is something that we call network slicing. And that's an architecture concept, which, if you talk to people in the packet core network, that is probably the number one feature associated with 5G from their perspective. And what we try to do there is to copy what you do in the transport. So in the transport, if you think about it, there was a transformation some 10 or 15 years ago where you went from physical transport to transport services. So now you offer transport as a service in form of IPVPNs, which means that you can isolate different customers logically, but you run in the same infrastructure. So that is what we want to accomplish with network slicing, that we want to create a logical mobile broadband network to give to Scania or lease out to Scania or lease out to other customers, so it looks and feels like your own private mobile broadband network, running in the same physical infrastructure as the others. And the tools to create these services have become available now with virtualization, at least in the core networks. Because it used to be that you have one monolithic node where you have all your subscribers. And to go in and change parameters and isolate certain subscribers in that node was very, very difficult. You could build that software, but it hasn't been done. Well, if you have a virtualization, you can instantiate the different packet core nodes so that you have one packet gateway, logical packet gateway per slice. And that means that you can configure the Scania packet gateway with the charging principles, with the quality of service principles, with the policies that fit the Scania use case. If you want to use mobile edge computing, you can make sure that this virtual gateway is moved out to the base station site or further out in the network, while a packet gateway that for some reasons should be more central for that particular service is positioned more central. In roaming situations, you can make sure that you get out in the roaming networks with your logical packet gateway, etc. So in this way, virtualization enables us to create isolation between different. We create really blue and red and green networks based on the same underlying infrastructure, and you can manage them one by one. that would reduce the risk of changing the touch timer parameters in one of the packet nodes that is associated with cars, that there's no way that that is going to impact the mobile broadband business elsewhere. And we can also start to maybe charge differently from the vendor side, find models so that we remove those barriers. How do you do that in the radio network? Well, we're working with virtualization in the radio network as well, so we can also instantiate certain parts of the base stations to create this kind of isolation, in particular the upper parts of the base station, and then you come down to spectrum. And there, in some situations, I think we can instantiate also that. For instance, when we have over-dimensioned, I think you pointed to that, Jens, that in certain situations, spectrum is not an issue. You can have plenty of spectrum in an in-building where you have put a lot of pico base stations or radio dots from Ericsson or something else. So in that case, you can even segment the spectrum in chunks and provide a guaranteed quality of service. In other situations, that is not possible. It's not possible today to guarantee 2 megabits per second to Volvo all over Germany, because you don't have the coverage and there are other users. So there we have to have used the good old quality of service and prioritization schemes. But I see that as a soft flaw or a soft problem in the network slicing concept. We can still provide this service, but we will not have perfect isolation in the radio network in some situations. But that is something that we're working on to solve. So I think I said that I would like to use this session to trigger some discussion and hear your good feedback. So maybe I should just stop here and let you feedback either now or in the panel session on these so-called soft barriers, and which of these do you think we can address, and which of these do you think that we have to solve by other means? And in particular, if you have any good ideas for how, which I can bring back in my job as a network architect, on what we should spend our time on, I think that would be very much appreciated.
We have time for a couple of questions from the audience. So, yes.
Okay, thank you, Erik. Yeah, you mentioned just now. You mentioned that the isolation at the radio access network side might not be that good as is that in the network side.
Yes.
Yeah. So, what do you think the main obstacle for this? I mean, is because that virtualization is not enough, or?
Yeah, I think that you have isolation from a logical view if you virtualize, but then you have the underlying resources, which means that if I start to use too much of the underlying resource, it may not be sufficient for somebody else. And that's why I think that the spectrum, if you're in a situation where you in the physical network you have built, you have only, say, a couple of megabits per second in this particular area, then all the users who are there, regardless of which slice they're associated with, have to share that 1 megabit per second. So that is the underlying problem, that it's a cost issue to provide spectrum in the wide area. That's why I think it may not be an issue in areas where you can over-dimension the radio network. Now, the practical problem, to me, is the lack of good KPIs and SLAs. I mean, in radio network, you have the only guarantee you can provide are statistical guarantees, that you buy a voice service from me and I will guarantee that you get dropped only 0.2% of the time, and I measure that in the network. That's my guarantee to you. And if you can measure that, you can start to give at least statistical guarantees in the slices. You can say that as a car, you will have 2 megabit per second in 98.5% of the cases, and then you will have at least 200. We can see that from measurements, and you can check that yourself. But we haven't formed those kind of industry-wide KPIs and SLAs, and I think that is also one of the barriers actually for going from best effort services where you don't know what you get into SLA-controlled business services.
Yeah. Okay. Thank you.
Another question?
Hi. So when we talk about business and sort of the mobile ecosystem, what's your take on slicing versus net neutralization issues? Like, how could you deal with a good net neutralization but still provide slicing for some customers?
Yes. Difficult. I don't have a good answer to that. I think that we should look maybe at how you do in transport. There is no issue with about net neutrality. You can pay your way through a better service in the transport for business purposes. Maybe other people are better at answering this, but I think net neutrality is primarily for consumer services, that you should not favor some, like Facebook and others that have been a debate about that. So maybe network slices and priority and is tougher for that kind of services, but for closed private networks for a specific customer, I don't think that net neutrality will be a big issue in those scenarios. But I may be wrong. We'll see.
Thanks for the nice presentation, by the way. How far do you think we should potentially go with this network slicing? Very often it's on the core network, we differentiate the services, but you could bring it all the way to the radio part. You could even bring it to the level where one could say on a base station, we're just running an operating system, which are giving time and frequency units. Right, and then we could actually, let's say, like we're running different applications on a PC, we could be running different radio applications on the base station. So do you think? So how far do you think we should go with this slicing concept, going to the radio part, and should we even go so far that we could have independent software releases for the different slices, even in the radio part? Or do you have any opinion on this?
I think we could go all the way. I mean, as you say, you have different steps in creation, really isolation and separation of resources, all the way from very soft to very segmented and hard, even different software releases. And to me, that is a way of realizing the slice. I don't think anyone at Scania, for instance, cares about how we have realized this as long as we provide them with a service. So it's more a pragmatic way of how can we in the best way secure the services, the network slice types, which are asked for by the market. If there's someone for security and safety reasons, if you really want to guarantee stuff, I think the best thing, and if they're prepared to pay for it, maybe you can even have separated spectrum in that part, as you say, frequency and time slots for that particular. If they want features which are a special kind, why not have a special release or a special software? Why not even have a Huawei software running and an Ericsson software running on the same physical infrastructure? I can definitely see that happen in the future if that becomes the most cost-efficient way to realize the network slices that are requested by the market. I don't think that will happen short term, but I would not exclude it.
One more question, we can take one more question.
Thank you, Erik. I mean, when I listen at your presentation here, it seems the biggest barriers are actually not so much from the technology side, but that you have we have a lot of capabilities in the networks already today, actually in 4G, but networks are deployed and configured with a certain business model in mind, which means if you want to at the same time run another business model, you have a misconfiguration, and that's where you say the slicing and the separation makes it easier. The question is, I mean, there's some kind of alignment for this flexibility towards new configurations, business models, national roaming in some cases, in others not, and so needed. And this is maybe one version is needed towards the automotive industry, something else towards the, I don't know, utilities also. Where do you think is the platform for making this? I mean, this is now an alignment in the industry of, I mean, is it NGMN which should say we need a profile, or is it a GSMA? But then we are again in the telco community. Where do we have the body where we get the Scanias, the Volkswagens, the Toyotas, or the utilities into this discussion for finding the right part? I mean, it seems that there's a kind of an industry alignment somehow needed.
I think you're right, Joachim, and there are different ways to address that. I mean, the SLA and quality of service in roaming situations problem was solved for the voice service VoLTE by the means of a GSMA profile. That's one way to do it, but that was a rather high cost for one particular service. I don't think that scales out to other services. But it could be that automotive is a big enough segment. If you look at it, there are around 800 million cars on the planet. There are 8 billion people. It's reasonable that a subscription to a car is roughly the same ARPU as a mobile broadband user. So that gives you, that is about 10% if you have of the operator top line if you have 100% penetration. But say that is 5 to 6% increase in top line. Maybe that is big enough to motivate a GSMA profile if that can sort of enhance that. Generally, we from Ericsson are starting with the automotive industry. We have initiated together with some of our competitors and partners and customers, and also with the car industry, a consortium in Germany to discuss how to act in the different industry bodies for automotive and telco respectively, to try to align and to mediate problems and challenges from one side to the other, find common solutions. I think that's one way. The Alexander, what do you call it? Alexander Hook. The solution, nicer solution is, of course, if you can create a new, I like that, you can create a new architecture interface that all of a sudden makes water flow in a way that it couldn't flow previously. So you enforce a change in the industry by enabling an interface. For instance, in the case of national roaming and network sharing, if you can find the right architecture model there, I don't think that operators would hesitate to collaborate on building out coverage for the common good in certain areas of the country. So different ways to accomplish that, I would say.
Okay, so if there are no more questions, let's thank the speaker again and